Hi everyone, let's solve today's problem of the day, which is pyramid transition matrix. Now let's see what the problem is. So basically here we are being told that you're stacking blocks to form a pyramid. Now what blocks? The blocks are being represented here. So these are the blocks that we are referring to here. So what we want to do is we want to create a pyramid out of these blocks. Now each block has a color which is represented by a single letter. Each row of block contains one less block than the row beneath it and is centered on top. Now to make the pyramid aesthetically pleasing, there are only specific triangular patterns that are allowed. A triangular pattern consists of a single block stacked on top of two blocks. So the patterns are given as list of three letter strings allowed, which is given here. So basically, these are only the allowed patterns or basically the blocks, right? So if you see B, C, C, right? So this block is here, C, D, E, the block is here, C, E, A, the block is here, F, 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 the block is here, okay? So these are the blocks that we are referring to. So these are only the allowed blocks that we want to use to create the pyramid, okay? So now we are also being told how we have to structure these blocks, right? So where the first two characters of a pattern represent the left and right bottom blocks respectively, right? So the first two characters basically mean the left and right bottom blocks. So for example, if the string is B, C and C, so first block is going to be on the left like this. The second character is going to be on the right like this, and the third character is the top block, so this is going to be here, right? Similarly for CD, you can see C and D on the left, right, and E is on the top. Now for example, so which I just explained to you, now you start with the bottom row of blocks bottom given as a single string that you must use as the base of the pyramid. So basically they're also giving you a bottom string, so which is this right here. Now this is a single string and we need to use it as the base of the pyramid. So if I combine all the information that is given here, we are given a bottom which is going to be the base of the pyramid. So like this is what we are given, and then we are being told that we want to create the pyramid using these blocks. So now we have to just see how we can create the pyramid using these allowed values. So they're saying that given bottom and allowed, now what we need to do is we need to return true if we can build the pyramid all the way up to the top such that every triangular pattern in the pyramid isn't allowed, or false otherwise. So basically what we want to do is utilize these patterns and try to create the pyramid. If we can create the pyramid from this particular given bottom value and the allowed values here, then we have to return true, otherwise we have to return false. So I hope that makes sense, right? So let's try to run this case, right, for BCD. Now, if you see B, C, and D, so with this bottom, let's take this as the bottom. We want to fill these two values. Let's create the pyramid first. So this is the structure of the pyramid. Now we want to know the values here, right? Now the values can be any, right? So there can be multiple pyramids as well for this particular bottom and using these allowed values. But we just want to tell that whether it's possible or not. If it is, then return true, otherwise false, right? So if you see for BC, there is only one pattern where we have BC as the bottom. So obviously it is going to be C here. Okay. So this pattern is followed with this block. Okay. Now CD, is there any bottom here? So C and D, yes. So we can fill this value as E. Okay. And then CE, is there any bottom value as CE? Yes. So we can fill this value as A. All right. Now we were able to build the pyramid using this as the bottom layer and using all of these allowed values, right? So we return true here. All right, so now I hope the question is clear. Let's also try to run for this one. So if you see, the bottom value is this and allowed values are this. So let us create the bottom here, A and A. Let me give the pyramid a structure here. Okay, and this. Now let's see if we can build this pyramid. Okay, now with AAA, right? So with AA, we have two choices here. Okay, so first is AA, the first choice is B and C. Now I can have either B here or C here. So basically there can be multiple So basically we have to, try to explore the multiple possibilities here. Okay, so B, let's try this out with B. All right, now let me also create a pyramid right here. A, and A. And let's place C here. What if it can be C? Then next value is again A. We again have two choices. So let's put B here. All right. Now, let me create. So if you see, given the number of choices, and we have like three um, blocks here that we are wanting to fill. So seeing this, there are going to be six number of possibilities, right? So let me create six structures for you right here so that we can easily visualize. Right. Yeah, I think this should be enough. Now, what other possibility can we have here? B, B. Let's say here we have B, B, and C. Here we have, sorry, B, B, and B. Let's say here we have B, B, and C. Let's say here we are going to have B, B, sorry, B. Let's make it as C, C, and C, right? So these are all the possibilities that we are going to have with B as the first starting character. Now with C as the first starting character, we can have first possibility as this, then second possibility is as this, then third possibility as this, right? So now we have explored all the possibilities for level 3 of this pyramid. Now let's try to build level 2, right, for all of these possibilities. Okay, so with B, B, is there any possibility of the allowed pattern? Yes. So here we can have E. Now if you see, there is only one possibility, so we of course know that this level for this particular pyramid is going to look like this. Now with B, B, and BC, do we have possibilities? For B, B, we know E is going to be the possibility. For B and C also we know that D can be there. So yes, we can use this and build this particular pyramid level like this. Now moving on to the next possibility, B and C. We have only one, which is D. Let's place it here. Then for C and C, if you see, there is no allowed pattern with CC as the base of a particular block. So we cannot create this particular level for this possibility here. But still we have these possibilities, right? All right, now let's try to build here as well. So if you see this particular level, so you realize that CC again is not within any allowed pattern. So again, we cannot build for this particular possibility. Again, for this particular possibility, we cannot build because CC is at the bottom of a block. Then for CB, is there any possibility? No. Again, for this one, we cannot build. So now only these two possibilities there where we have built the level 2. Now let's try to build the level 1. So now if you see as EE of the base of the block, again, there is no possibility. So we cannot build for here. For this one, let's see. So we have ED. Is there any possibility? No, there is no allowed pattern as ED for a block. So again, for this possibility, we cannot build the pyramid. Now you see we have explored all the possibilities and we are seeing that it is impossible to build for this particular bottom and allowed values, right? So we return false here. Okay. So I hope now the question makes sense as we have tried in both the cases. Now let's see how we can solve this particular question, right? Right. So if you see, what we are essentially trying to do is we're trying to explore the possibilities and try to see whether we can build the pyramid or not, right? And in such questions, obviously, when we are talking about exploring all the possibilities, what we use is recursion, right? So what we can do is recursively try to build all of these possibilities, right? And try to build the pyramid. But if you take a look at the constraints, right? Can we use recursion to solve this or will we have to optimize it further? So if you see, the allowed length is 216, the bottom length is 6, and the letters in the input strings are going to be from the set this. So now just take this, right? So basically we have six possibilities for this particular cell. If I want to fill this, right, there are six possibilities for that. Now at each and every level, so let's say the bottom level has n values. So this level we already know, but if we see the next levels, those are the levels that we want to build. So if we want to recursively build those levels, then we will start from n minus 1 as the cells, right? So basically with six number of possibilities, we want to explore for n minus 1 cells here. So for that, the time complexity will be 6 raised power to the n minus 1, correct? Similarly, I'm calculating for the first case, right? Similarly, if you keep moving level wise level, so for each and every level, so we'll be adding these cases, right? So it's going to be 6 raised power n minus 2, sorry, it's going to be multiplied, then 6 raised power n minus 3, and so on till 6 raised power 1. That is for the first cell. So for the first cell, there will be six possibilities, of course, right? So if you see, this value computes to 6 raised power n minus 1 plus n minus 2 plus n minus 3 plus and so on till 1. So now what this value becomes nothing but 6 raised power n into n minus 1 divided by 2, right? So which is essentially a big O of 6 raised power n square. Now if you see what is the bottom length values that we can have, so n is 6 here, right, in the worst case. So which is still computes to 6 raised power 36, which is a very huge number. Thus we cannot, use recursion to solve this problem, as it will give us TLE. So rather now we have to optimize it. So for recursion, how can we optimize this? So now we know that there can be cases, right, that I have tried to build for this particular case. Let's say for this one, right? So as EE as the bottom, as BBB as the bottom. So what we can do is we can try to memorize these values, right? So if we just record, we'll keep a record of, okay, if this is the bottom, is it possible to build the pyramid, right? Because what matters is the bottom only. So if I'm using this bottom, is it possible that I can, build up to the top with this bottom value? No, right? So this is the value that we are going to memorize. So after each recursive call, right, we are going to memorize whether a particular bottom, right, whether that particular bottom helps us to build all the way up to the top, or if it is a failure case. So what we will store against these bottom values is true or false, so that if we encounter this particular case again in any other recursive call, I can basically pick that particular bottom value from within my memorization table and basically see, okay, for this one, it is possible or not, right? So I can save myself creating the multiple recursive branches. All right. Okay, so now let's see how we can do that, right? Now that's important. All right. All right. So we just discussed that this problem can be solved using recursion plus memorization, right? Now let's try to build a solution and dry run it. Okay. All right. So how can we basically solve this problem? Right. So the very first thing to, start with the recursion itself is to know how many recursive calls that we have to do, right? And what are we doing this recursive calls for? So let's take this particular case, right? So let me create this A, and A. Now for each of these cells that we have, to fill up the pyramid, we are going to make the recursive calls, correct? So for this cell, we will explore how many possibilities we have. For this cell, we will explore. For this cell, we will explore. And we'll keep exploring. While we explore, we will also, memorize the values of these bottom layers, whether it is possible for this particular bottom to lead us to a pyramid or not, right? So because what matters is just the bottom, correct? So now this memorization, you already know why we are doing it. All right, now let's see how we can explore the choices for this. So in order to explore the choices for this, I need to know when the bottom layer looks like this, that is A, how many choices can I have for this particular cell? So that I can only know if I can, record it somewhere. So what we will do is we'll create a hash map for this, so that it will help us in our recursion to know what possibilities we have to explore. All right. So let's take example of this particular case only. All right, so what we will do is from the allowed values, we'll create a allowed map here. All right, now within this allowed map, what we will store is the key is going to be the bottom two blocks. Okay, so for the AAB string, the bottom is AA, right? So inside of my map, I will be storing AA, and then against it, I will store what are the possible values for this. So I'll iterate it. So for the first, from the first value for AA, I get B here. All right, then from AAC, I get C value here. Then I see if there are any other AA values. So obviously it will not go inside of this. Now let's create for the next bottom key value, that is BC. So for BC, I can see it's only D value here, right? Then let's create for BB. Similarly, for BB again, I have only E value here. Then let's create for DE, right? For DE, I have only F value here. Now, if you see, I have created this particular map. Now, this map will basically help me to realize two things. First, that can we, with a particular, bottom layer, can we create a particular, fill this particular cell here. All right. And second, how many possibilities can I explore with a particular bottom layer, right? Okay, so now I hope that is clear. Let me also create the memoization map here for a dry run. So let's just call it memo. Now in memo, what are we going to store? We are going to store a bottom layer, right? So let's say this layer BBC. So once we have figured, okay, this once we have completed this particular bottom, right, we'll keep building. So there will be two cases. Either you will stumble on a layer from where you cannot build on top of it, so you know that okay, for this one I cannot build it, so you will store this inside of memo. So let's say for example ed, you cannot build above it, right? So against this ed string, against this ed string, I will be storing a false or true value, so we can know that with this particular bottom layer, can we build on top of it or not. All right, so this is the values that we are going to memorize. All right, now let's do a dry run, right? So this particular map we create before recursion, of course, and now we go straight into the recursion. All right, now as I mentioned, the recursion is going to be for each and every cell as we are trying to explore the possibilities. Okay, now let's start with the recursion. So when we have a, right, I'm just building the layers here. Okay, all right, so now right now we are exploring for this particular cell. Let me just remove the other cell so it doesn't cause confusion. So first we are building for this bottom layer, but we are recursively calling for this particular cell. We want to fill this. So for this one, if you go into the allowed map, you see there are two values that can be, possible for this cell. So it can be either B or it can be either C, right? So with this as the possibility, my pyramid now looks something like this. For this possibility, my pyramid now looks something like this. All right, now after creating for this, let's build for this particular cell. Again for this cell we have two possibilities, B and C, right? So the pyramid is going to look like B and B in this case. For this one, my pyramid is going to look like B, C and this, right? For this particular cell, again, let's open this up, recursively call A, and A. And for this one, it's going to be C. For here, we are again exploring the two possibilities B and C. So it's going to be C, B, and this. And for this one, it's going to be A, and B. Sorry, it's going to be C and C, right? So it's going to be C and C and this. Now, again, we have two possibilities here, again, two possibilities here, again, two possibilities here, again, two possibilities here, right? Now, go and build for this one. It'll look like, let me just, put the bottom layer here. So it's going to look like this, okay? Then for this one, it's going to look like this. For this one, it's going to look like B, C, B. For this one, it's going to be B, C, C. For this one, it's going to be B. Oh, for this one, it will be C, B, and C. For this one, it's going to look like C, B, and C. Okay, it's going to be B here. All right. For this one, it's going to be C, C, B. For this one, it's going to be C and C and C, right? So these are the possible values. Now we have to figure for the next bottom layer now. Okay. All right. Now we'll recursively move forward. But I hope now this is making sense how we are doing the recursive calls, right? Okay. So now for BB, so B as the bottom layer. Again, we go and see it in the map BB. We only have E as the option, right? So there will be two recursive calls, one for this, and it will be filling up EE, right? So it will look like, now the pyramid looks like something like this: A, B, B, and B. We had already seen this E, and here nothing. Okay, this is not going to be the case, right? Of course. After this, there will be one more recursive call for this only. A, and A. Right. And then B and B and B and E and E. All right. Now we'll go further into this recursion, right? So once we go further into this recursion, we realize that there is no allowed values here. Thus, we cannot basically build on top of this, right? So level 1, we cannot build from this recursion tree, right? With this recursive branch. All right. So what we now do is we memorize the values. What values we memorize? We now know with this bottom layer, right? We are within this recursion. We will have to backtrack as well, right? So with this EE, we cannot go further, right? So we memorize it here. We just store the string EE and against it a false value, so that again if we encounter this, we do not have to move into any recursive calls to see whether we can build with this as the bottom. All right. Similarly, when we backtrack, we realize the bottom layer was BBB, so we store for BBB as well. We memorize for it, again we store false. Similarly, we keep opening up all these branches. Now if I try to open up this branch, so B, B and C, right? So with B, B the possibility is E, and then for B, C the possibility is D, right? So there will be again two recursive calls. One is going to be E and one is going to be D, right? And it will look like A, and B, B and C and E and D, right? Now on top of it, again if you see within our map, we have no other values, right? So we cannot store here. All right. So again we memorize the values. So it's going to be now ED as false, and then for BBC we again know it's not possible to build, again it's going to be false, right? Okay, now let's try to see for this particular recursion call, right? So this way you can see there will be many recursive calls here, and for each of them we are going to memorize the values as well. Now after each and every call, what will happen is we will keep backtracking, right? So from this particular branch we are getting the answer as false, from this branch as well we are going to get the answer as false. So we keep on backtracking and we keep on getting false here. So we had already dry run the example for this case, right? I'm not trying to open up the whole recursive tree here, but you can visualize this right here, that how we are going to get false for each value, right? So after we get false, so we are going to get false for this as well, we're going to get false here from here as well, we are going to get false from here as well, and finally for here. So basically the overall answer that we are going to return is going to be false. So this is how the recursion works. Now let us see how we can code for this, right? So here's the code, right? Okay, so as I mentioned that we have to do recursion, and we have to also create a map here. Okay, so all right, so this is the helper function which will help us to perform the recursion. Okay, and here is the main logic. So first we have to create the allowed map that we just did, right? So first value is going to be the string, which basically represents two characters, which is the bottom of the block, and vector char, because we want to know how many values are possible for that value, right? For that bottom value. Okay, so we have to create this. Then we have also created our memo map. So within our memo map, you can see the string that we are going to store. Now this string is nothing but the bottom, and against it we are going to store a boolean value to know that with this particular bottom, have we already encountered it? If yes, is it possible to build the pyramid to the top with this particular bottom value, right? So we basically store a true or false against it. So that is our memo um, table. All right, now what we do is first we create this map and then we start with the recursion. Okay, so for this, to create this map, we are basically traversing allowed, and for each and every substring 02 pair, so basically this means, let's say if we have AAC, right? So for AA string we are storing C here. Okay, so this is how the map we are creating. So allowed map key dot pushback the third value here. All right, then what we are doing, we are simply returning helper 0. So what is 0? All right, so we are doing it index by index. Now what does this index represent? This represents nothing but the index of the bottom. So let's say if I have this, right, A and A, so this index value basically tells me which particular cell is it on this bottom layer that I'm trying to fill. Okay, so for this case, the index value will be from 0 to 2, right? So that is the index, so that I know which particular cell the recursive call is for. Then string next bottom. Next bottom basically represents this level that we are trying to fill. Then string bottom is nothing but this, so that we know, okay, what is going to be the base, right? Then we have the allowed map values, of course. Then unordered map, this the memoization map. All right, now are we doing the recursion? So this is the base case for the recursion. So let's say if the bottom dot size is equal 1, return true. So if we have reached to the first cell, okay, that is bottom dot size is equal to the 1, right? So this is the topmost level. If we have reached that, that means we have created the pyramid, right? So we are returning true from here. Then next base condition is um this is not the base condition. All right, so if index is equal bottom dot size minus 1, all right, so which this basically means that if this is equal to bottom size minus 1, that means we have created the whole bottom, this bottom layer we have created. Now after we have created this bottom layer, what we are trying to do is that this bottom layer we are finding within our memoization map, have we already encountered this bottom before? If we have already encountered, simply tell me whether is it possible with this bottom layer or not. So we are simply returning the memoized values. If we have already encountered, let's say BBC, and the value for this was false, right? So that basically means for this particular bottom layer we cannot build on top of it, so we simply return that. Otherwise, if we have never encountered this as the bottom, we keep the recursion continued. Now here we are again starting with 0, so this is where we're basically going to the next bottom layer and doing recursive calls for there, right? So we start from 0 index, then we obviously the next bottom we have not started creating it. The next bottom value we are giving, because next bottom is what we just created. Now this is the next bottom and this is the top layer on this particular bottom that we are trying to create. So that is why the next bottom value we are passing here, then we are passing the allowed map and the memo, right? All right, then again we are trying to memoize for this next bottom and then we are returning this as well. All right, then string all right, now here we are doing the recursive call for each and every of this cell. All right, so we are taking index comma 2, basically we're figuring what this particular block is. Now for this we are using this for loop to explore the possibilities, right? So basically within the allowed map, we are seeing, okay, how many possibilities are there? And for each of those possibilities, as you saw within here, that we had B and C as the possibilities, right? We are doing the recursive calls. So those recursive calls we are doing from here. So we are just passing index plus 1, that is, do the recursive call now for this, since we have done for this, next bottom plus the character that we choose for this particular cell, and the bottom and the allowed map and the memo values, right? And then return true. All right, so this is basically how we are doing the recursion. Now, of course, if we are unable to create the pyramid here, we are returning false, right? If, and the pyramid is only created if we have reached the topmost layer or the topmost level, so that's when we are returning true. So I hope I was able to help you with the solution for this particular question. So yeah, that is it for this question. Thank you.